Hi everyone, we are going to be naming ionic compounds today. So I'm going to show you how to do that. There are several steps that we'll go through, and I'll just walk you through each step through examples. Okay, so don't worry about this. And we'll start with CaCl2. So we're going to try to name this here. So the first step is we want to name the name of the metal first. So go ahead and find Ca on your periodic table. What's the name of Ca? Ca is calcium, so that's the first part. The next part is we take the anion and we change that to an IDE ending. Okay, so the anion is the negative part. So calcium is the positive part. So chlorine is going to become chloride. Notice that IDE ending. Now, combine those two together. Always write the metal first. And what do you think the name of this ionic compound is going to be? Calcium chloride. There you have it. Let's try another example, and we'll do those same steps here. So first, you just write the name of the metal. What is the name of Mg? What's the name of this metal? We're looking at MgO. So what's the name of Mg? Magnesium. And oxygen, oops, gave that one away. How do you think we're going to change this anion here? What would I put in this spot here? What do you think? Oxygen becomes oxide, and then altogether the name is going to be magnesium oxide. All right. Seems pretty easy. Well, it does get a little more complicated. Sometimes you'll be given polyatomic ions. So these have more than one atom as part of the ion. But the good news here is that I'm going to just give you the names of these. Normally I'd have my students remember it, but this year I think I'll take it a little easier on you. So here we just have to figure out what the name of this metal is, Na. OH is going to be hydroxide. So what is Na? If Na is sodium, then now we just want to name the entire ionic compound. If we put those two together, always write the metal first or the cation first. What would the final name be here? Just sodium hydroxide. You don't have to change anything about this hydroxide here. Okay, just use that polyatomic ion name. All right, let's try one more of these. We have NH4Cl. We're looking at this ionic compound. And so the cation here is our polyatomic ion. It's NH4 plus 1. It's called ammonium. And so what would we change chlorine to? Remember that we do want to have that IDE ending. So what would chlorine become? So chlorine becomes chloride. And then now if we combine the two things here, what would our final answer be for the name of this compound? This would just be called ammonium chloride. Okay. Last thing, some metals have multiple oxidation states or charges. So that means they can form more than one cation. So for example, lead here can be +2 or +4. So it's up to us to figure out which one are we using, because we're going to have to use Roman numerals to indicate the different charges. In case you forgot your Roman numerals, it goes I for 1, I for 2, I for 3, IV for 4. You don't need to know anything past that. So we're given two formulas here, PbCl2 and PbCl4. So how can we figure out the charge? Which metal am I using here? So I know that chlorine, each chlorine is -1, and I've got two of those here. So if both of these equal -2 total, which lead do you think I have? +2 or +4? Remember, the ionic charges need to cancel out. So we got to have a +2 charge here to cancel out these two chlorines. So when we name it, we're going to use the Roman numeral to indicate the charge. So I'm going to write lead, and then in parentheses, I'm going to put the Roman numeral 2. Again, that 2 comes from this charge here. And then the last part of it is going to be lead chloride. Okay, and this is our final answer. Let's look at the other lead chloride here. We have PbCl4. So now I'm looking at this. And now I've got 4 chlorines. Each one has a -1 charge. Which lead do you think I have here? Is it Pb +2 or Pb +4? So this one is going to be, this 4 should be here. This is going to be a +4 charge in order to cancel out all those chlorines. So when I write my name, what do you think the name of this is going to be? How about you try this one? We're going to put lead IV chloride, lead 4 chloride. So again, that +4 or that 4 is telling me the charge of my lead. Let's try another example. Last example here. So iron is also one of those that can have different charges. It can be +2 or +3. So here we got to figure out which one we have. So if you don't like drawing out all of these different ions that I did here, I'm going to show you another method. Remember the crisscross method we learned? Well, we can work backwards to figure out where did those numbers come from. So here, if I work backwards, that shows me that oxygen has a -2 charge, and if this 3 goes up here, that tells me that I'm working with lead +3. So here, basically what I did was I did a reverse crisscross. And that'll help me figure out the charge that I'm working with. You can also figure it out by looking at each oxygen and then looking at your 2 irons to figure out what charge it has here and here. Okay? If you check the math, if each iron's +3, it'll work out. So here, if I'm dealing with iron, what would be the name of this cation? Remember, we want to use Roman numerals. So what do you think? I'm going to put iron 3, okay, because it's a +3 charge. O is the anion, so how would we name the anion? Remember, we have to change the ending of this O. So what would the anion be called? Oxide. And then lastly, we want to combine all of these together. So when you combine the cation and the anion together, what's going to be our final answer here? Iron 3 oxide is our final answer and final